Welcome to the GOTO Podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Welcome to another episode of the GOTO Book Club. My name is Stefan Hofer. I'm a consultant and coach, and I model domains, business processes, and software architecture using different notations and diagramming techniques. I have also written a book about one, domain storytelling, and I had the pleasure of being interviewed for this channel. Today, I am the interviewer, and I could not have asked for a better book to discuss. Today, we are going to discuss creating software with modern diagramming techniques, build better software with Mermaid. The author is Ashley Peacock. Ashley, welcome to the GOTO Book Club. Do you want to introduce yourself to our viewers?
Yeah, hi, I'm Ashley Peacock. I live in the UK. I'm a staff level software engineer for a UK insurance company. I've been diagramming for a very long time. And as Stefan said, I wrote a book all about it called Creating Software with Modern Diagramming Techniques.
Awesome. So let's talk about diagrams and not just drawing diagrams by hand, which is probably the most natural way to approach diagramming, but also diagrams as code. That is a concept that I believe has become quite popular in the last couple of years, and you built your book around this concept, or the notation, the tooling you use is built around that. Can you give us an introduction to diagramming as code for someone who is not familiar with that concept yet?
Sure. So historically, if you wanted to draw a diagram, you might reach for a tool like Visio, or more modern ones such as draw.io, diagrams.net is really popular these days. And you essentially use the UI to draw boxes, lines, label the lines, and so forth. That works well. So if you're just getting started, but it has problems. For one, it can be a little slow. But the other kind of problem comes from the fact that it's not machine readable. So if you ever look at the format that diagram is saved in, you won't be able to read it, right? No one can. You can't diff it. You can't version control it. So what diagrams as code does is it allows you to write your diagrams as you would write HTML, for example. So there's simple markup, and it takes that markup and converts it into an image, effectively. Is the simple way to put it.
Mm-hmm. And do you still have control over the layout then, or is that completely generated by the tooling?
So it depends which tooling you use. In some, you have more control than others. So a really kind of modern one is called D3. And that gives you a lot of control over the layout, but it's more similar to writing code than it is diagrams as code. It's still diagrams as code, but it's more like writing, Java or C#. With tools like Mermaid, for example, the notation is super simple, and you do have some control over the layout, but perhaps not as much as you might like. You kind of have to have an acceptance that it might not look as pretty as if you drew it by hand, but that's the trade-off you make for having ease of creating the diagram and version control and all these things. So I guess it's like most things in software engineering, it's a trade-off.
Yeah, so less control, but less moving stuff a pixel to the left or to the right. So that's then one of the advantages if it's generated, right?
Yes. One of the other benefits being you can also, you can store this. So, and by store it, I mean, if you're storing on draw.io, for example, it's stuck in draw.io. So if me and you work together and you leave the company and go somewhere else and it's on your draw.io account and you leave, suddenly we no longer have access to to that diagram. Perhaps it's quite common for companies to kind of wipe people's Google's account and so forth. Whereas if you've stored that somewhere else, because it's, it's just text, it's readily available, much more accessible.
All right, great. Now, you apply this diagrams as code approach to several different diagram types and notations in your book. Can you give us a brief overview before we go into the technical details of how Mermaid works? Can you give us a brief overview which diagram types and notations did you choose, which are covered in your book?
Sure. So I'll go over 3, because I cover a few more in the book, but I think the 3 main ones that I use most commonly, and the 3 I find most useful, in no particular order. The first one would be a sequence diagram. So this is how you model interactions between either, it can be services or it can be kind of people, if you like. So people in like a business process, for example. And the way it works is you have essentially kind of nodes. So you'd have kind of, maybe 2 here and lines going between them. And it just shows the interactions between those things. So let's take, if you're building, let's say a service, let's say an application that allows users to sign in, and you want to model that sign-in flow. You might have, the front end that makes an API call to the back end with the credentials for the user, and the back end might respond with, the 200 OK, for example, and the happy path. And the sequence diagram allows you to model those flows in a way that's kind of very visual and very easy to understand. The second one would be the C4 model. And that's written or created by Simon Brown. And it's a way to model your software architecture. So it can be quite hard to model your software architecture sometimes, or have to describe it sometimes, or show it to other people, right? It can be really complicated. So it's a very nice way to get different views of your architecture. So there's 4 different views in the C4 model, so that's where the C4 comes from. The first one, I'm going to cover 2 of them because I think the latter 2 are not quite as used as much, but the first one is called context, and it's a very, very high-level view of your architecture. So it's meant to be non-technical. It will just be systems and how they interact with each other. So it gives you a very good glance at what each system is doing in the architecture. You can think of it like the responsibilities of each service in the architecture and the users that are using those services. And then the next view down would be container, which is described as the single deployable units. So if you had, let's say, a backend service that's built using Rails, and you had a MongoDB database, those would be 2 containers, and then you would describe the interactions between those. And then the other 2, you drill more down. So you go into like components, which are like namespaces or modules, and then you can go into classes, but you're then getting really, really into detail. So I don't normally do those ones.
Okay, great. So we have 2 sequence diagrams and C4 model, which itself is like a set of abstractions and diagram types. And what's the third one that you want to discuss?
So the last one will be the domain model diagram. And that's kind of, as it sounds really, it's a way of describing the problem domain that your software is working in. So if we take this recording, for example, we're recording on a bit of software, and you might have, participants might be something in your domain. After we've finished, you might have a recording, there'll be something in your domain. You have speakers and so forth in your domain. You have all these domain entities, and it's just a way of documenting those what's in your domain in a diagram and describing the relations between them. So does each participant have many recordings or one recording and so forth, things like that.
If I want to categorize those 3 notations or diagram types, sequence diagrams are defined in the UML, so it's like very formally defined, right? C4 is more like a set of abstractions. Different notations are possible, and it's defined by Simon Brown. And the last one, the domain models, that's more like a free form, not really defined. There's no standard for that, right?
That'd be correct, yeah.
Okay, so that means that Mermaid, the tooling that you describe in your book, is able to do all of that. So it's a broad spectrum from formally defined model languages to like free-form modeling. Everything is possible with that tooling. Would you agree with that?
Yes. I think it has a kind of base set of diagram types that it supports. So it doesn't have a domain model diagram type, but it does have something called a flowchart. Mm-hmm. And the flowchart is kind of like the most generic diagram type you get in Mermaid. So you can kind of do whatever you like with it. So if you have a diagram that doesn't fit into the normal types, I would use a flowchart. So in the case of in the book, I use flowchart for the C4 model, and I use it for the domain model diagram. Mm-hmm. Mermaid is adding support for the C4 diagram slowly into it. So it has like the native syntax. So you could use that now. It only supports, I think, the kind of highest level context diagram at the moment. And it also uses I think it's plant UML notation. So to me, it's a lot more complicated than normal Mermaid, because you have to learn a different notation, which is the plant UML notation. And finally, the sequence diagram is natively supported. So that's kind of its own diagram type in Mermaid with its own kind of syntax. But if anyone's ever used, UML, it basically uses the syntax for UML.
Okay, great. So now we've started to touch on the topic of Mermaid itself. So from diagrams as code, we move now to one specific tooling to create diagrams from code, and that is Mermaid. So how does Mermaid work? Can you give us an overview? What is required in order to use it?
Yes. So you don't need, you need JavaScript. So it's primarily written in, I think, JavaScript and TypeScript. So it has the kind of, I think it was the first one that I used that was easy to run pretty much everywhere, right? Because JavaScript runs everywhere. It runs in your browser. You can run it on the edge. You can run it on servers. You can basically run it anywhere, right? If you look at historically, some of the kind of perhaps problems with prior ones. So if you take the main one for it probably was plant UML. And that had all the kind of same diagram types that Mermaid has, but it was written in Java, which, Java's a fine language, but it doesn't run everywhere, right? You need to make sure Java's installed. You can't just run it in the browser. It absolutely doesn't run in the browser. So Mermaid kind of has this big selling point of that it's super easy to run wherever you want. And to explain kind of what it is, it's a tool for creating diagrams as code. The documentation is really, really good. So you'd be able to go on there, look through all the diagram types, and you'd very quickly be able to create diagrams from examples reading the docs and create all these different types of diagram. And then it will take what you write, and there's like a live editor, so you can do it live and it'll update it live. And then you can export images from that diagram if you want. And then there are some other things you can do that are really kind of its big selling points.
If I understand it correctly, Mermaid defines a markup language, or you would call it a domain-specific language for describing the diagrams in form of code. And then there's a tooling that's also called Mermaid to create the actual visual diagrams out of that code. So I could probably write Mermaid diagrams in my favorite text editor and then just apply the tools and have them generate the diagrams. Is that correct?
Yeah. So the Mermaid library on GitHub has many different kind of parts to it. And one of them would be, for example, like a CLI tool. So you could, if you want to, you could write a diagram in Mermaid and then use CLI on your command line to generate the images. Like I said, there's a live editor that again is part of the Mermaid package. It's all kind of open source.
So there is a live editor, so that's maybe nice for actually creating the diagrams or the first versions, maybe, so I can see like live, if I enter this line of code, this is how it's going to be rendered, which is nice for modular. But once I have the actual DSL file, I could like integrate generation of documentation into my build process because there are CLI tools available. Is that correct?
Yeah, you definitely could.
Okay.
The other kind of big selling point that I would say, and it's probably the main reason I started using it, is a lot of engineers these days, they use GitHub or GitLab, for example. They're probably the main two kind of version control providers. And while being able to do it with the CLI is nice, doing it in the live editor is nice, if you export an image out of these tools, which you could do with draw.io, right? You still then, and you want to store it in version control. Let's say you want to put your architecture diagrams in your README or in your repository with your code, right? Which is a really nice place to put your diagrams that relate to your code. So you might put your domain model in there. You might put your architecture diagram, your SQL model in there. Now, if you put an image in there, that's fine. That's better than having nothing at all. But what will happen, like I said earlier, is if you leave and you create that diagram, I have to try and find that file. And if I can't find that file, because you probably didn't submit it to, commit it to version control, I have to either redraw the diagram if I want to update it, which could take ages, or probably more likely, I can't be bothered because I can't find this diagram to recreate it. So with GitHub, GitLab, some others, you can basically take the Mermaid markup, so the simple markup, put it in GitHub in code tags with Mermaid, so the 3 backticks with Mermaid. And then when that markdown file is viewed on GitHub in the browser, GitLab, it will render that diagram for you with no work. So then you have your single source of truth for your diagram is stored in your code repository, and whenever anyone wants to view it, it will render it for you without any work whatsoever.
So that sort of integration is, as I said, it's a big selling point. But speaking of selling, you said open source, so I don't need to buy Mermaid, right?
Nope, it's all open source, so anyone can contribute. There is kind of there's a product they sell on the side, basically the people that kind of wrote it for you to kind of store your diagrams if you want. But the main primary library is all open source, and anyone can contribute, anyone can use it, and it's got beyond GitLab, GitHub, tools that you probably use like Jira, Notion, Trello, many others. They all have kind of Mermaid plugins that you can use.
Yeah, that's cool. So everybody is free to build their own plugins or their own tooling using the Mermaid DSL, and then every Mermaid diagram would also work with that plugin or that tooling that you've built on your own, right?
Yeah, exactly.
Okay, that's good. Do you know how long Mermaid has been around? I'm asking because, sometimes diagrams or notations change, get extended. Maybe it's not compatible always. So do you have any experience? Do the old diagrams created with earlier versions still work? How is that?
So far, I've not had a diagram of mine break. So I think they're very careful to ensure backwards compatibility. I think especially since they've been on, GitHub, for example, I think it would be a bad look if they suddenly broke, tens of thousands, 100,000. I don't know how many diagrams have been created on GitHub. I assume it's very, very high. And like I said, its big selling point, I think, is the GitHub and GitLab integration. So I think if they would want to look after that integration, I think. They do add new ones. So like I said, they're constantly adding new diagram types. So besides kind of the ones I talked about, you get, class diagrams for, modeling your code. You can even do things like, Gantt charts if you want to structure your kind of releases or something like that. They have kind of mind maps for like ideation, and they're adding kind of new ones all the time. In terms of how long it's been around, I can't remember when it was released. I don't think it's definitely not like old. I would say it's probably been around for, I think, about 5 years, but I wouldn't want to be quoted on it. But it's still relatively new, and it does have a very active kind of contributor base on GitHub, so it is very well maintained.
Mm-hmm. Yeah, I think that plant UML has been around for a bit longer, so that's another diagrams as code approach that you've mentioned earlier. It's only its own language and its own tooling. That's one I've used before. Another one another tooling, another diagramming language that I've used before for the C4 model is Structurizer, the tooling by Simon Brown. I'm sure there are other toolings out there that I haven't used before. Do you want to pair them a little bit with Mermaid. So you brought up a point already with the GitHub integration. So maybe that's the selling point, as you called it, for Mermaid. But maybe you can expand on that a little bit.
Yeah, sure. I would say that the differentiator is definitely the kind of the fact that it's available on GitHub. It's its biggest selling point for sure. But besides that, I think earlier on I talked about how plant UML is written in Java, which makes it you can't just run it everywhere, right? The setup is not easy. If you you'll find things online for editing plant UML, but if you actually want to kind of run it locally, for example, in your IDE, there are probably plugins for it, but it's a bit more annoying. You have to install Java, so forth. With Mermaid, you don't have to do that. The DSLs, like if you'd used Plant UML, for example, and you haven't heard of Mermaid before, and you're interested to try Mermaid, if you want to migrate, the syntax is basically identical because it's UML syntax, so it's at least for the most part for Mermaid. So you'd probably be able to take all your diagrams written in Plant UML and just put them in Mermaid and maybe a few minor tweaks, and everything would just kind of work. So then you get the benefits of Mermaid without any pain of migration, really. Structurizer is specifically made for the C4 model, and it has its own kind of DSL that is specific to that. I've used it a little bit. I think it's slightly different because it's a modeling tool, right? So if you were creating a backend service that was called, I don't know, I'm going to call it the backend because I'm terrible at thinking of names, like most engineers. In the structurizer DSL, you would define the backend service, and you might say it's a Ruby on Rails service, and you define that once, and then anywhere you use it, you just kind of reference that model because you've made that model for your for that thing. With Mermaid, it's a simple DSL, right? So you'd have to maybe, if you're doing two versions of the C4 model that I talked about, the content and the container, you would have duplication between the two. And if you wanted to change the name of one thing in all of them, you'd have to go change it all and so forth. Yeah. However, if you wanted to model, because modeling is slightly different, if you wanted to use that model as I spoke about, you can do it in Structurizer, and then you can export it to a bunch of different languages. So you can export it to Mermaid, you can export it to Plant UML. I think it does D3 these days. It does all sorts. So while it is its own DSL and it's very specific to the C4 model, you can still get Mermaid from that tool if you wanted to then put it in version control, for example.
Okay, that's good. And if you have a diagrams as code approach, like with Mermaid, refactoring doesn't sound as scary anymore. Renaming stuff is a lot easier if you have it in your IDE, maybe some support there. You check it into your repository and everything is fine. They know that it still works, right?
Yeah, exactly. And because it's, if you're using GitHub, for example, you could, when you raise the PR, you just click and view file and you'll see it looks fine. And one of the other kind of, it's in me and you were working on improving or changing our domain model that we work on together.
Yeah.
You might raise a pull request, but if you were doing, draw.io or something where the format is completely unreadable, or just an image, it's really hard to diff an image, right? If you look at it, if it's quite big, it could be hard to see the nuance in it. Whereas with Mermaid, because it's just text, you would easily see what I changed. So if like you just said, if you rename something and maybe I missed one or something, you would easily be able to see in the diff that I missed it, most likely anyway, because it's just text, but used to kind of reviewing diffs in that way, right? So yeah, it's really easy to do.
Now, as I said, I've used a little bit of Plant UML and Structurizer before, so I found it easy to transition to Mermaid. I had actually never tried Mermaid before I read the book. So your book does a very nice job in guiding readers step by step to applying Mermaid, starting really simple. You have your first diagram like with, 3 or 5 lines of code, and then expand on that. And then you go through the different notations that you've described. And we see like, okay, some have like their own diagram type, like native support, and others use a more general one, and then you adapt it to your needs. So that is really easy to follow in your book. And I would assume that also people who have never used a diagrams as code approach before will have an easy time getting starting with Mermaid if they read your book and follow the examples.
Yeah, I think so. That's the general feedback I've had, I think, especially because engineers, as you know, they're used to writing complicated code, and simple text-based markup is pretty easy for anyone to grasp. So yeah, I think it's pretty easy to get up to speed with.
Yeah. So I'm curious, why did you decide to write a book about Mermaid and diagrams as code? There's a quite good documentation also online regarding the tooling. So why the book? What got you there to make this decision? It's a lot of effort to write a book.
It is. I think many years ago, I remember, I guess everyone that does diagrams maybe has their kind of epiphany moment where they kind of realize the kind of power of a diagram. I'm sure you have your own. And I hadn't written any diagrams before. I didn't know what UML was. But I was trying to explain things at work and no one was getting it. And I maybe couldn't even explain it that well myself, which is probably why they weren't getting it. But I was kind of just throwing kind of words at them, if you like. And I drew a very bad diagram. It wouldn't have been based on any kind of diagram I knew because I didn't know anything. But then everyone suddenly got it and I got it better and I could explain it better. So at that point, and this was many, many years ago, I could kind of see the power of diagrams. And then I started I don't remember when I saw Mermaid the first time, but I kind of saw it and thought, oh wow, this is really cool. And I started playing around with it. And I had a look at diagramming books. I was curious if there was a book on Mermaid, for example. And even just looking at diagramming books, there hadn't been one written for like 15 or 20 years, something ridiculous like that. The last one, and I think it was like Uncle Bob or someone wrote one a long time ago. All about kind of UML, for example. And things have moved forward a long way since that time. So I thought, there's lots of things have changed. I'll write a book. It seems like there's a gap for more modern, newer engineers. They're probably not going to want to read a book about UML because while UML is very good, it has a bit of a kind of old school reputation, I would say. I don't think it's rare you kind of work with someone, they kind of whip out a UML diagram these days, right? But at least with Mermaid, it makes it seem a little kind of more cool, a bit more kind of easier to use. You haven't got to draw. It's an easier sell, if you like, is probably why I wrote the book, and just to kind of bring that to modern speed, I guess.
My takeaway here is that Mermaid makes UML look cool again.
There you go. You could say that.
Okay, but actually it's about more than UML, or your book is about more than UML. And this is something that I think is a benefit over just reading online documentation that is provided for the tooling, because you have an opinion on what diagrams and what notations to use and when to use them. So you made a conscious choice which diagram types to include in your book and describe them with Mermaid. So maybe let's go back from the concrete tooling with Mermaid a little bit to the topic of diagramming and modeling in general. So you had the sequence diagram, you had the C4 model for architecture, and the domain model. Why these and not some other? Why not BPNN or whatever?
So I think when I wrote the book, and this partly comes from the publisher, Pragmatic, they like it to be kind of hands-on, and as you go through the book, it should model kind of real-world things, and there should be kind of activities for people to do. Because if you kind of read a book and don't do anything, it's kind of, you don't learn as much if there's activities for you to do during the book, and then if you go and do them, it kind of reinforces that learning. So that's their general approach. And I'd never written a book before, so I was very happy for all their kind of guidance and their direction. But as you kind of go through the book, I kind of tried to make it like you would do your day job if you were building a brand new service, and you'd go through different stages, right? So you might, a business requirement comes up for you to do this thing, and you realize, maybe you're starting to work in a brand new domain. So the first thing you're going to need to do is understand the domain with a domain model diagram. So the first chapter is on domain modeling and drawing a domain model. You then might want to talk about the sequence flows, understand the interactions that you have going on in your system. So that could be people, services, and kind of understand a very high level, because sequence diagrams are super high level, the interactions and how your system is going to talk to your current existing systems, for example, and then see how that plays in. And then again, you might then define your architecture with the C4 model, for example. And then I think it goes into things like you might decide how you want to structure your code base. So you might reach for class diagrams, and you don't need to model, all of the classes that you're ever going to write, because that's going to take a very long time. But you might just kind of play around with how you want to kind of organize your code with class diagram. And similarly, you can also use class diagrams for refactoring. So, if you jumped forward 6 months, you might have a need to do some refactoring. You're going to have maybe loads of classes at play, and maybe it's becoming a little bit tricky. Maybe you made a bit of a mess somewhere, and you just want to understand how everything fits together. So you draw a class diagram, and you can kind of very quickly and easily rearrange them with Mermaid. So it's one of its, another one of the selling points is you can iterate really quickly. So if you were doing a domain model and you wanted to change, you wanted to try out different names or different relationships, you could do that in, a few minutes, versus if you're in a meeting with someone and got to draw the boxes and move them all around, it's going to be really painful, both for the person and everyone watching while they move these things around, versus you can quickly iterate them with things with Mermaid.
Cool. Before you said you researched other and also older books on this topic of diagramming and modeling, some even like 20 years old. If we were now in 20 years from now and some new developer was exploring what the forefathers wrote 20 years ago, and they would discover your book, I believe that, I don't know if Mermaid will still be around in 20 years, or maybe it's a completely different version, and the DSL code might not be valid anymore. But nevertheless, I would argue that your book would still have value, because it's not just about Mermaid. It's about those diagramming techniques and also when to apply them. So there's some advice there, even if you don't use Mermaid itself. Maybe some other tooling. Yes, the listings of code, of course, they only make sense with Mermaid. But there's some more general advice there for how to use diagramming in order to build better software. So that's what I really like about your book.
Thank you very much. And maybe if you jump forward to those 20 years in the future and what things might look like, I think one thing that's starting to happen, it hasn't kind of quite got there yet, is it would be really cool if you could draw these diagrams and you could turn those diagrams into real things. So this is starting to happen a little bit. I can't remember the name of the tool, it's escaping me now, but there's one where you can draw things on like AWS using their stuff, and it will take that diagram and deploy it in AWS. I saw it kind of the other day. And obviously these days, let's say you like the idea of Mermaid, but you don't want to learn the syntax. Everyone these days knows about ChatGPT, and ChatGPT is an expert on Mermaid. So you can the other day, literally yesterday, I was working on something with just some friends, just on a side project, and we were talking about how you design the database, and that's one of the diagram types I actually forgot to mention was you can actually use an entity relationship diagram to model your kind of database using Mermaid. That's the diagram type, and we were kind of just talking about it out loud, and one of the guys, he couldn't quite grasp what we got to, because we now had like 7, 8, 9 tables. So he drew out on paper, but I was like, well, we could just draw it with Mermaid, and I basically just told ChatGPT, so here are the tables, here are their relations, and it in 30 seconds I had a diagram. I had not even had to learn or draw anything from Mermaid. It did it for me. So I think it's really powerful.
So that's one way, from a description to a formal architecture diagram. But you also said from a diagram to running software. So maybe we'll see a rebirth of model-driven architecture or model-driven development. So that was, in my opinion, like interesting approach like 20 years ago, but never really, at least not in general purpose software development, never really kept the promises that were made with that. But maybe with the new tooling and AI, it deserves a second chance. Who knows? So I'll see a new book on the horizon by Ashley Peacock.
Perhaps.
Okay, Ashley. Is there anything else that you want to mention that we haven't discussed yet?
No, I don't think so. I think if you're interested in the topic, you're interested in the book, it's available, on Amazon, creating software with modern diagramming techniques. You can go get it today. And hope you enjoy Mermaid.
Great. I enjoyed talking to you, enjoyed your book. And I'm looking forward to your next one.
Thank you. Thank you for thanks for doing this with me. I really enjoyed talking to you about it. Thank you.
Sure, it was my pleasure. So that was our episode on the book Creating Software with Modern Diagramming Techniques, Build Better Software with Mermaid by Ashley Peacock. See you for the next episode of the GOTO Book Club.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.